In this video, we're going to talk about atomic number, mass number, and isotopes. Atomic number, which has the abbreviation Z, is simply the number of protons. So we've got a little piece of a periodic table here with several elements. You can find the atomic number on the periodic table. It's the whole number. It's not always on top like this, but these are the atomic numbers for these elements. So boron, B, has an atomic number of 5 because it has 5 protons. Carbon has an atomic number of 6 because it has 6 protons. The number of protons is always equal to the number of electrons if you have a neutral atom. So all the atoms on the periodic table are neutral. So boron has 5 protons and it also has 5 electrons. Isotopes are atoms with the same number of protons, so they're the same atom, but they have different numbers of neutrons. For instance, uranium-235 and uranium-238 are 2 different isotopes. If you look for uranium on the periodic table, you'll see that it has atomic number 92. So it has 92 protons. Okay? It happens to have 143 neutrons for this isotope and 146 neutrons for this isotope. Can you see where that came from? If you add these together, you get 235. If you add these together, you get 238. We're going to see that this number is called the mass number. So the mass number is their number of protons plus neutrons. So uranium-235 had 92 protons because that was its atomic number. Remember, it also has 92 electrons. And you just subtract 235 minus 92 and you get 143 neutrons. So these are the 2 isotopes of uranium. This is how you write their name. You write the name of the element dash mass number, which is abbreviated with an A. Okay, and then write the symbol for uranium. Okay, this is what it would look like on the periodic table. Uranium. And on this top left-hand corner, we write its mass number. And on the bottom left-hand corner, we write its atomic number. So that's the nuclear symbol of that isotope. Can you write the other one for uranium-238? Why don't you take a second and see if you can do that. So hopefully you got something that looks like that. And those are called the nuclear symbols. So a few little examples here. An isotope of antimony, which is Sb, is used as a tracer to detect leaks in oil pipelines. Now, you don't have to memorize that. I'm just trying to make it sound a little more interesting. This isotope has 73 neutrons in its nucleus. What's its nuclear symbol? That's what we just learned to write. So we find antimony on the periodic table and we see that it's number 51. That means that it has 51 protons. So antimony, so Sb, 51. And then how do we figure out its mass number? Well, we take 51 and 73 and we get 124. Okay, so this is that's its symbol, and this would be its name, antimony-124. Right, so mass number, atomic number. One of the most harmful components of nuclear waste is a radioactive isotope of strontium, which is Sr. What happens is it gets deposited in your bones and it replaces the calcium. So how many protons are there in the nucleus of strontium-90? Well, we find strontium on the periodic table and we find its atomic number is 38. So the number of protons are 38. How many neutrons? Well, all we need to do is take 90 minus 38 and we get 52 neutrons. And if you wanted to write the symbol, it would be Sr90 over 38. And we would call it strontium 90. Write the nuclear symbol for the isotope for an element with 54 protons and 79 neutrons. So again, we have to find number 54. So it's an isotope of xenon, Xe. We put the 54 here, and then we just take 54 and 79, and we get 133. So it's xenon. So again, that's the nuclear symbol. Its name would be xenon 133.